Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and we're right between the K&T and the closing. We're back on the gear. We're going to be getting this in here real soon. We actually, from our last video, I've actually taken that and set it up in here, and I went through. We put a bar through here. We indicated and set up our index head. After we did that, we put in our shaft, and we ran into the first problem. The arbor that we have over here has got a 5/8 national course thread in the end of it, and it has a 60-degree bevel which we could run a center, but my tailstock center that I have to run over here on my mill is 3/4 of an inch, and then it has an oddball cut over here, and it's offset, and it doesn't come out to the width needed to run the center on the end for support. So we're going to be coming back over the lathe here, and I took a 5/8 bolt, went into the Rutland lathe, and we precisionally drilled a center hole in the end of there. Okay, as we were saying, after we drilled that center hole in that bolt and put it in, we put the shaft in the mill, and we put the tailstock up there. After we've dialed this all in, we found that we actually have some run out on that end. We were able to get within a thousandth or so on each side of our sleeves and our gear running on there. We know that this chuck runs, I can run, get things to run at least a thousandth, and I'm trying to shoot for at least the minimum amount that we can set this up and cut those gear teeth. All right, so let's bring you in close, and I'm going to show you how I have this set up, what I'm doing to fix a center drill that's not running true. All right, sometimes big shafts and things like that had to come in many times and reclaim a center drill, especially these crazy guys that got pullers and they think they can twist right into that center drill and think I put that specially in, or somebody put that specially in for them to center up with their puller. All right, let's check it out. All right, we got you pointed over here. We have this set up. I have the light adjusted, and I think you got a good view of both of our indicators. Here's our Intrepid here, and our stair at 1-inch travel here. We've dialed this in to where it is running less than a half a thousandth here. We are supporting our arbor on the sleeve that rides true right next to the gear, and then we've indicated the sleeve on the other side of the gear, and also double checked with the gear itself, so that we can create a true center here in relationship to this 40 taper here. This will guarantee that this end of the bar is actually running true, and we're going to skim this taper inside the center drill to match the run out of the bar right now. We're reading down about 5 thousandths to one side of that zero and 2.5 to the other side, so we're good strong 7 thousandths run out on that center drill. All right, we need to make that run true because that center is actually holding the shaft off a little bit, and we need to have the axis of the shaft rotate equally so that we're putting gear teeth equally around the piece of material we're trying to put gear teeth in. All right, and we're just trying to do this as close as possible because we can. We can make, sometimes you're limited on what your machines can actually do, but we know that we can make this run truer. So we're going to take a high-speed tool bit, and I'm going to pan you out, and I'm going to show you how I reach in there and remachine that taper on the center drill. Okay, I just want you to look at this tool bit here, and you can see that it's real shallow underneath here, high angles. All right, and this is just got plenty of relief on the bottom inside. All right, so it's just basically a real sharp point that we can reach in there, and the cut or rake is off the back side there. All right, and I got it set for center height. I adjusted from this lower section down here on my lathe. All right, yeah, Hootie's out there talking. All right, I'm going to go ahead, put this in gear, and we can run at about that speed right there. Now I'm going to go ahead and put some Sharpie in here so that I can see when it cuts. Okay, it's full of Sharpum. Now I'm going to come back into this, and I'm just going to be feeding with my compound here. I'm going to lower that down a little bit. That was pretty good. We're going to come in a little bit and we're just going to touch. There we are. Okay, I can see it skipping. Coming back out. Okay, let's go ahead and remove it from the lathe and set this up in the KNT. And I need to open just a little bit more here. There we go. Okay. Okay, and let me get my my lube for that. Okay, little extreme pressure lube there. Give it just a little bit of travel so we can have some adjustment in there. When I'm setting things into 3-jaw that nice and close, I like to give it a slight little bit of a roll. It really helps align chuck and items you're chucking on. And then go ahead and bring her on down tight. Tighten that up there. All right. Now we'll go ahead and check her out for run out. Okay, we got 2 indicators on here and we're actually able to sweep it around. I got them tilted here so you can get them in the right perspective. We're running a little less than 1 there, and I'm running about 1 1.25 here on the gear itself. Alright, we're going to set up the index starting point here and start setting up our center line for our gear. Okay, this is a pretty good test here for noise because I actually had to put the fan on because we got a heat wave again, so we're doing good. I'm normally right-handed, and I would normally hold my scale with my left hand and crank with my right hand, and so I'm actually controlling the crank on the mill with my left hand here. What I'm going to do is we're using this top surface here of the gear cutter to be our horizontal, and then I'm going to come in and touch and get the feel of this surface here by going like this back and forth, and I'm going to touch this off, and that's how I'm going to get the height of these 2 components at 0, and then we'll go from there. I just bring it up slow. just barely feeling that. I had to reposition to make sure that I'm getting it square on the top of that gear, and it made a couple thousandths difference. Okay, I'm gonna set 0 right there. And we had to wipe off our dial. We keep oil smeared over this machine all the time just so it doesn't get rusted out. Alright, and our mark is straight up and down right there. There's our 0. Alright, now let's pan out a little bit here. Okay, this dial here reads 1/8 of an inch full revolution. This diameter is 5 inches. That cutter width right there is 236. Half of that is 118. Half of 118, which would be center of this up to the top, away from the 2.5 inch half of diameter, will leave us 2 inches, 382 will be our total amount to crank up and have that cutter be centerline with this gear. Alright, so first off, we kind of look over the edge here and make sure that we're not going to crank the gear up to our part, and go answer that phone. Okay, as I was saying, we got to come up 2 inches, 382, and we got 1/8 inch on the crank here, so we know we're going to be going at least 16 times cranks to get up to 2 inches, and another 4 to get up to 2.5, but we're going to be shy of that. So let's get up to 2 inches right now. Okay, that's 2 inches right there, and we need to go 382. So 1, 2 takes us to 240 or 250, and 250 from 382, 132. So we go 1/8 there. That's 125. 130, we said 132, 132. Alright, right there should be center. Alright, we're going to take our scale and we're going to put it on the part there and verify that the tool bit is holding it flat against or 90 degrees to the part, or if it's leaning out or if it's leaning in, will tell us if we're up or down. And I'll bring you in at the other end here. Okay, we're holding this over here and we're kind of getting it right in line with our tip of one of the flutes. Alright, making sure that it's not touching anything here. Alright, now we're going to stand the square up here. Okay, see how square that is? Alright, you know that you are center of your part, or that is a good way to verify that you're on your mark for center of the part. Alright, so we're ready to cut our teeth and pick up our scale. Okay, let's shut that off, and before I do anything, the very first thing I do is I set my vertical to 0 here, and I pull the handle off and I put the handle away. That way I don't accidentally bump that during this whole process and move anything up or down. So with that set, now we can go ahead and start concentrating on starting our indexing and then touching off and then starting our cut. I'm going to bring you around here because I want to just briefly talk about the index head and its part that it plays in creating gear teeth evenly around your object. All right, so let me move you on over to this other side here because I think it's going to be a little better view for you to capture everything about this index head. All right, an index head takes gear ratio and increments of indexing on this plate. And actually there's 4 plates. This, I happen to have 2. There's one here, there's one here. They face back to back to each other. There's another set that you can put in, you can change them out. This is plate 1 and plate 2, which cover the majority of everything that this Model K index head can do. But there are some gears that I just can't index because I don't have the right plate to index that in. All right. With that said, this actually indexes for the amount of teeth. And the gear ratio between this shaft and this is 5 to 1. All right, and we'll go through that in a minute. Now, there's another shaft, that output shaft on the back here, that actually you put gears here and you pick up your table for constant helical motions, and this is 8 to 1 in relationship to this. And combined, that 5 and the 8 puts this out at 40 to 1. 40 turns here to 1 turn here. And this is standard. Some of the gear ratios between what this is and what this is changes between the manufacturers because of patents or whatever the reasoning is. But I just know what this one here particularly is. But this cog here, spline, gears mount on here, and you pull this off of here, and there's adapters here that you can put on assembly, and it carries a gear train, and that's how you get helicals. Now, even if you're using helicals, you're still using the index head, but you are loosening off the brake so that it combines the 5 and the 8 to 1 to get you the 40 movement, but you do still index to actually move your gear teeth in relationship to that helical. The helical just goes back and forth when you're moving your table back and forth, but this will index your teeth. All right, now that we've gone past where we're actually at, but just explaining what the index head here is, let's look at it from the other side. All right, the first thing we did was determine the pitch of this gear because that helps us pick out the cutter for that pitch. Every pitch has got a set of cutters to cover that pitch size. That pitch size cutters, there's 8 cutters per each set. And that takes you from a flat gear, which these thread pitch gauges represent here, all the way to a pinion, which is the smallest drive gear that you can start out on your gear train. And each one of those cutters is set for a certain amount of teeth. So I have that 16 pitch, and that's what we found this to be, was 16 pitch. Right here is the rack gauge, and it matches in there very nice. Now I also have a gauge that was given out at the Bar Z Summer Bash, and Bruce Whitman blessed us all with these gauges there, and this goes from 4 to 32, and in between the lines is where it has that combination, because this is the proper gear for this diameter here. And let's come on over here. Here's 16 over here, and that's 16, so we can work those couple teeth right there on that gauge right there and know that that's a 16. If you were up here on your 14, it wouldn't match in, and it won't match in when you get down to your 32. All right, and this is the back side there, and that's all Bruce's information. You should be able to pick these up from him. All right, now that we have the pitch and we have the cutter picked out, let's get into setting up the index to cut these 78 teeth. And that is what you have to count all the teeth, even the ones that are missing, to make the gear the proper amount of teeth. Okay, I've got the actual Model K owner's manual for this index head. And I don't know, this index head may be as old as this mill right here, and this may be, you know, from the 60s vintage or somewhere around in there. Anyway, this actually lists the index plates on these pages right here, and there was 6 plates. I only have 2, as I mentioned before. I thought there was 4, but there's actually 6 plates. So I'm actually missing 4 out of the 6, but I do have plate 1 and plate 2, so I can play with this aisle, the first columns here. All right. The gear we're cutting has 78 teeth, and we come down here to 78 divisions. And we're going to be using plate 1, and there's actually a whole circle that has 78 holes around it. And our movement is going to be 5 holes. So each gear is only going to be 5 holes on the 78 circle there. Okay, let's put away the book line here. All right, I'm going to take the break off of here. Notice up here I put a 0 and I put a line and I put a Sharpie line right here. In line at this position. This is the pin plunger, okay, and it pulls out, it's spring loaded, and the pin goes in and out of these little tiny holes. We're going to turn that to the side. All right, this is up at the top, and I'm just going to rotate this around 5 times, and we'll be coming back up to our 0 right here. But each time I go around, you'll see that I put a line there, and this is the 5-to-1 ratio, and we're going to be cutting our teeth around, and I just like to work clockwise on my dial here. Okay, comes all the way up. There's our first round, second round, third round, fourth round, made the whole gear. Okay. All right, let's take a look at the holes now. This is a pin plunger, and this pin and plunger goes into the little holes. Now up here, straight in line, is the number holes. That tells you each number for the amount of holes in that circle. We're working the third circle down, and you'll see that little blue circle there, and that's 78 whole circle divisions. Okay, this is a spreader that you set for your holes that you're gonna go from one to the next hole. So I've got it set to be on the back side of that, and then forward 5 holes to your next one. So when we pull it out of there, it goes into here, then you move this here, then you go into there, and it goes all the way around. The 15th gear comes up here, and then you have a remainder of 3 before you come back up here to the top. This is only one. Remember, that's the 15th gear. We got 78 teeth to make. Okay, so we got to go around this thing 5 times. Well, 5 times 15 is 75, and we have a remainder of 3 gears, or 3 teeth on the gear. All right, so there's 1, 2, 3. Just, you know, it happens to be in the math here as well, because this is a 5-to-1, and 1/5 of the 0.6 remainder, because that's what it is. 5-to-1 divided into 78 is 5 equal amounts of 75, and a remainder of 0.6, which 0.6 times 5 equals 3, and that's how we get the remainder into the divisions, and that's why the 78 works with the 5-to-1 gear ratio. All right, this spreader, when we set it there and we come all the way around, our 15th hole, the spreader will be locked into there, and then you can see that the next span of 5 takes you to the second hole. Then you're going to be on the next path, you're going to be working that second hole all the way around. And on your third pass, it's going to come up here, and you're going to end up be working on the 4th hole. And then your 4th pass around, you'll be working back on the 3rd hole. And then when you come up to that 3rd hole here, your next move will be lining up with exactly where you were 5 turns from now. All right, that's how we're going to get those teeth cut in that piece of ductile iron. Okay, on the spur gearing here, in fact, actually, just let me put my scale in here. This is another reason why machinists invented flexible steel scales. Okay, so you can see that we're on the diametrical pitch of 16, and our equivalent for circular pitches is 0.1963, and our standard circular thickness is 0.0982. Our standard addendum is 0.0625, and our working depth is 0.125, and standard dedendum is 0.0723, and our whole depth of tooth is 0.1348. All right, so that information's all in there, and then we were able to go ahead and take and hold up our gear to the light and put our vernier gear tooth calipers up there, and you can see very clearly that the thing is almost stock dimension right out of the book. And that's what we're going to cut it to. All right, so we're going to go ahead and set up, touch off, and plunge in for our first cut. Okay, I'm just instead of firing it up and spinning it and sticking my head over there until I see it skip material there, I'm just hand cranking this in and rotating it by hand until I feel it just barely touch. Okay, I'm gonna call that 0 right there, and we're gonna set our dial at 0. All right, now we're gonna go ahead and we're gonna crank her back, and I think I'll fire it up now. I'll answer that now. Okay, I think we're finally ready to go here, and we picked 58 RPMs as our RPMs, and we decided, and we measured up everything there. We're gonna crank this in for 100 thousandths on our first pass. Actually, let's go ahead and we're going to crank it in 120. That should leave 10 thousandths for a finished cut. Bring us up till where we touch. Okay, we're touching. All right, here we go. We're feeding. Right now it's a 1/2 inch per minute. We're going to take a look at that until it gets in there with the full cut. And then we may crank this up to about 1 inch a minute or so. We'll go in small increments. We're playing with our stop so that when we get to the end, we're going to set a secondary stop. So we'll have a stop at both directions. when you're cutting gears, if you get that stop set up, you can go do some other things while gears are cutting. All you gotta do is come back and index it. Okay, we're going to go ahead and speed her up a little bit. We're going to speed it up to an inch a minute. Now a lot of people are going, hey, why aren't you running coolant on here? This is ductile iron, and I don't want to create a wet slurry and put the ductile material floating around in between the ways of the machine. The same as if it was turning it on the lathe. I keep that material separated at all times. Okay, that's out past halfway, and just about any time now my stop will stop. It doesn't have to be exactly right at the end. It's just a safety thing in case I want to walk away, and I'm just making sure that it kicks it out. And it kicked it out. Okay, and now we can run it back to our other side there. And it kicked it out there. All right, our first valley is done, and now we're going to index to the next spot. And there we go. 77 more times.